Okay, thank you. And you can hear me, can you?
Yes, we can hear you.
Great, perfect. So yes, so thank you very much. And first of all, I want to apologize that I won't be around too much in the discussion sessions, which is really a pity. I would love to, but unfortunately I chose my travel days just days before the dates for the conference have been announced. And so unfortunately can't be around too much. But for the talk, I chose this title, Why a Little Bit of Causal Structure is Necessary Even for Functionalists. And the reason that I chose this topic is that lately there's been a lot of debate surrounding so-called causal structure theories as opposed to functionalist theories, most prominently surrounding the discussion of the unfolding argument by Adrian Durick and also Johannes's work, of course. And as you probably all know, the causal structure theories, such as integrated information theory, IIT, but also recurrent processing, are those for which the implementation, the causal model, matters to determine whether a system is conscious or not, whereas functionalist theories supposedly only care about whether a system performs function X, but not specifically how. And first of all, I don't think that this distinction is nearly as clear-cut as one might think. But today, I want to argue that a purely functional theory without any regard whatsoever for causal structure is incongruent with consciousness. And first, one issue here is that most of the empirical work in the science of consciousness is focused on one question, and that is, how can we tell whether someone is conscious or not? Because this is the question with a lot of clinical relevance, obviously. And the clinical standard is still about responsiveness, right? So we also know that conscious experiences arise from our brains, and that the contents of these experiences have somehow to do with neurons firing and with their interactions. And we can use this knowledge to even address hard cases where people might not be able to respond because they might be paralyzed or something. This is just an image of the famous study where researchers asked the patients to imagine playing tennis. And so the brain states could be used instead of vocal reports, right? But the essence of this all is that there's still this notion that there should be some means to tell just by interacting with the system whether the system is conscious, right? And if we take this notion and apply it to all possible systems, then we arrive at something like a Turing test for consciousness. And the problem here is that obviously from the fact that I can determine in a human being that they are conscious by interacting with them, doesn't follow that the same holds true if I want to test any sort of physical system, right? The Turing test, as you also probably know, initially wasn't meant to test consciousness at all, but it was meant to test for intelligent behavior. So what actually can be observed during the test, not some hidden variable like consciousness. Another thought experiment that does address consciousness in some sense, at least, is the Chinese room argument by John Searle. And I'm sure you all know it, but basically the setup is that there is a person in a room and that person has no idea of Chinese, but they're given questions on paper in Chinese and they have a big rule book that tells them what the correct answer should be. And in that way, they can output the right answer. And from the outside, it looks as though whoever's in the room or the room is perfectly capable of answering questions in Chinese. But the person inside obviously doesn't understand the questions and answers. So the problem with the Chinese room is that, first of all, or what I think is the biggest problem is that it's not clear whether the setup is actually feasible. Right, and so it's not clear if you can pass the Turing test with a simple lookup table. And also Searle's original presentation emphasized understanding, but it's also clear that the person inside is not conscious of answering questions in Chinese, right? So because of the criticism to the Chinese room, I want to provide us a simpler setup that doesn't have the same set of issues, but for for this purpose, we have to move beyond the simple consciousness yes/no question, right? And my argument is that how a system does what it does matters once we ask about the contents of the experience. And if you want to know more about that, you should listen to Matteo Grasso on Thursday in hour 3. He's going to talk about maps and grids and the difference between the two of them with respect to their capacity for spatial experience. But today I want to talk about the question, who is experiencing, which is the individuation problem of consciousness. And I argue that to answer that question, you need to use causal interventions, and you can't solve this issue just based on input-output functions. So back to the Chinese room, one of the replies to the Chinese room argument is called the system reply, where people accept that the person inside the box doesn't understand Chinese, but the room as a whole, they argue, might well understand Chinese. After all, it looks as though it does, right? And the point, I think, might be valid with respect to understanding, but with respect to consciousness, it's a bit trickier because I think few would say that the room becomes conscious and understands Chinese, and second, in any case, the person inside the room is still obviously conscious. But as I said, there are some issues with whether this is even a plausible scenario. And to go around that, I want to introduce my thought experiment, which I called the Greek cave, just for a change. And it's a very simple setup that is obviously possible, which like in the Chinese room, you have one person in this enclosure in the cave, and that person doesn't speak any Greek in that case. Let's say he's an English speaker, or they are an English speaker. So there's also two more people in the cave. One is a bilingual who can translate questions from Greek to English, and the other can translate those questions back. And if we look inside, obviously this is feasible. Obviously the Greek cave would pass the Turing test. After all, there is a person inside answering questions. But the point, so it has the advantage that it's feasible, but the point is that even given that setup, we can still conclude that there is no person inside the cave that answers any questions in Greek. And therefore, it would be wrong to conclude that there is one conscious being that must perform this complex task. And the more general argument is that any complex input-output function can always be distributed across different numbers of consciousnesses. And therefore, pure input-output functionalism isn't sufficient. Individuation is the argument requires causal interventions. So if you, there's obviously a very easy way to tell that there are three people in the cave. You just go in and talk to them individually, right? But doing so amounts to causal intervention. So if you want to identify the monolingual speaker and his questions and his identity, you have to go in and you have to disrupt the causal chain of events, and you have to ask them directly, and you have to ask them in English. And right. So again, the conclusion of this all is that no theory of consciousness can do entirely without assessing causal structure. Now, that actually, this argument implies that a very simple test for any theory of consciousness is that if you apply it to a room full of people, the theory should be able to tell you how many consciousnesses are in the room. Otherwise, it's not a complete theory of consciousness. And in this case, I have 3 people in the room, so the answer should be at least 3. 3 that we sort of know of by good argument, right? So there is hardly a theory of consciousness today that can address this problem without presupposing that there are 3 brains in the room to start with. And it should be noted that if you count the brains, you're basically applying a causal structure, right? So you know that there are brains that is physical. You're taking the physical composition of the room into account. So this problem should be solvable given just this big neural network, and as I said, there's hardly a theory that even tries to do this, and I think that is a problem, right? So it's the problem of systems, subsystems, and supersystems, and this problem has been also pointed out by this paper here by Fekete and van Leuven and Edelman. And it's basically the only other account of this issue that I've seen in the literature outside of IIT. So we have maybe this conscious agent here, but if we just look at the interactions with its environment, then how can we actually say that where its borders are, right? What the system is. And for consciousness, we need an observer-independent way of identifying the borders of a system. And the theory of consciousness does have to solve this problem. And the issue with all these functional equivalence claims that have been put forward, or I mean, one issue with those functional equivalence claims is that they always require predefined systems. And as we've outlined in my paper on causal composition.
2 minutes.
Thank you. You can have like a system, a key of 4 interacting units where 3 are supposed to be the agent and 1 is the environment. It's a simple system that walks through all of its possible states. And it has this subsystem ABC also goes through all its possible states, dependent on the state of the environment. If we keep the environment fixed to 1, it will go through this order of states. If we fix it to 0, so the other way around. Now we can permute the order of the functional states, and that will lead to a different physical implementation. And while you can say that the 2 systems as a whole are still functionally equivalent, this is not true for the subsystems. So when you're changing the causal structure of just one particular subsystem, you might interfere with what counts as the environment, the agent, and so on. And so to end, as I have probably 1 minute left, I just want to go through 2 possible objections to my thought experiment. And one objection I thought of was that a lot of people will conclude that there's at least one conscious being inside the cave, so it's not a big deal, right? So the question whether it's conscious at all or not is more important than identifying how many there are. And my response would be that's maybe true and maybe not. The argument doesn't really depend on whether any function can be performed entirely without consciousness, but it's still true that there is no person inside of the cave that is conscious of answering in Greek, right? And the second objection could be that the observed brain states of the monolingual may be used to identify them as conscious of answering the questions, right? So a machine state functionalist might say, oh, I can, if I had like the brain recording of the 3 people together, even if I'm not like told whose neurons are whose, right? I could find a mapping between the monolingual and someone who's actually answering questions. After all, the monolingual is answering questions, right? That's true, but the three people system still also performs the function. And if that is to be excluded, then functional equivalence is insufficient to identify conscious entities. And the alternative would just be enormous proliferation of conscious systems. And as a last note, I just want to point out the analogy of the thought experiment with sensory inputs as bilingual 1 and then motor outputs as bilingual 2, and identifying the actual neural correlates within the brain. Right? So, and that's it. And I want to thank you. And I have a blog post on my blog, Consciousness Realist, about this topic that you can check out to reread if it was too fast. Thank you.